Three of California's volcanoes are among the most at risk in the country for a catastrophic eruption. Nightbeat's Maria Medina with what would happen if they did erupt.
Every time a geyser erupts in Yellowstone National Park, it seems to spark a wave of sensational headlines foretelling the apocalypse. Headlines such as Yellowstone Volcano Warning, Supervolcano will erupt and could end human civilization dominate the media, capturing the attention of millions and stoking fears of a catastrophic end. The internet often reacts with a frenzy of doomsday speculations, with Yellowstone portrayed as a ticking time bomb. However, few people spare a thought for another equally significant volcanic threat, the Long Valley caldera, which the United States Geological Survey, USGS, also classifies as a supervolcano. Despite the intense media attention on Yellowstone, scientific studies have highlighted Long Valley's potential for devastation. A groundbreaking study published in Geoscience World in August, titled Seismic Evidence for Significant Melt Beneath the Long Valley Caldera, provides a stark reminder of the volcanic threat posed by this region. Conducted by USGS researchers at the California Volcano Observatory in Menlo Park, the study utilized advanced three-dimensional full-waveform tomography technology. This technique involves analyzing sound waves as they travel deep within the Earth, enabling scientists to create detailed images of underground structures. Their findings are nothing short of remarkable. Beneath the Long Valley caldera lies a vast magma reservoir exceeding 240 cubic miles in volume, of which 27% is sufficiently hot and in a molten state, making it capable of fueling a massive eruption. To put this in perspective, if all this magma were to erupt, it could produce a cataclysmic event rivaling the magnitude of Yellowstone's last supereruption 640,000 years ago, which formed its famous 35 by 50 mile caldera. A caldera, for those unfamiliar, is the vast depression left behind when the ground collapses following a massive volcanic eruption. Yet, despite these alarming findings, Long Valley remains largely overshadowed by Yellowstone. The reasons for this discrepancy may lie in Yellowstone's iconic features, such as its world-famous geysers, steaming hot springs, and dynamic geothermal activity, which draw millions of visitors annually. Meanwhile, Long Valley, though also rich in geothermal activity with its hot springs, fumaroles, and even the Casa Diablo geothermal power plant, lacks the same level of public recognition or media allure. Both regions, however, exhibit significant volcanic activity, ranging from earthquakes to minor eruptions of magma, gas, and rock. Perhaps Long Valley's relatively low profile stems from a lack of dramatic public imagery rather than any real difference in the volcanic threat it poses. When comparing their histories, Yellowstone undoubtedly takes the lead in terms of sheer scale. Long Valley's last major eruption, known as the Bishop Tuff event, occurred 760,000 years ago. This eruption expelled approximately 150 cubic miles of magma, making it the third largest supereruption in geologically recent history. However, according to the new research, Long Valley's current magma reservoir contains enough molten material to support another eruption of similar magnitude. The Bishop Tuff eruption was an event of staggering proportions, forming Long Valley's present-day 20 by 10 mile caldera and releasing over 2,000 times the volume of material ejected by the 1980 Mount St. Helens eruption. The devastation was immense. Pyroclastic flows of glowing hot ash buried much of east-central California, airborne ash traveled as far east as Nebraska, and the Earth's surface sank by more than a mile in some areas as the magma chamber emptied. Yellowstone, on the other hand, has produced three massive supereruptions over the past 2.1 million years, with intervals ranging from 600,000 to 800,000 years. Its largest eruption released an astonishing 600 cubic miles of material, dwarfing Long Valley's output. The resulting ash plumes spread even farther, blanketing vast regions of North America and leaving a geological record of destruction that captures the imagination of scientists and the public alike. Despite these comparisons, the potential danger posed by Long Valley should not be underestimated. Volcanologists recognize that both regions are capable of producing eruptions of unimaginable scale with the ability to alter the global climate, disrupt ecosystems, and threaten human civilization. Yet Yellowstone continues to dominate the narrative while Long Valley quietly simmers in the background, its story often overlooked. Perhaps the disparity in public perception comes down to marketing. Yellowstone, with its dramatic geysers and awe-inspiring geothermal features, steals the spotlight. In the end, both Yellowstone and Long Valley remind us of the dynamic and unpredictable nature of our planet. While Yellowstone often steals the spotlight, Long Valley's potential for devastation is equally compelling. It may be time for scientists and communicators to bring Long Valley's story to the forefront, ensuring that the public understands the full scope of the supervolcanic risks lurking beneath our feet. The United States is home to 3 active supervolcanoes, according to the United States Geological Survey, USGS: Yellowstone in Wyoming, the Long Valley Caldera in California, and the Valles Caldera in New Mexico. While Yellowstone garners the most attention for its geysers and geothermal features, the other 2 supervolcanoes are equally significant in terms of their geological potential. Among them, the Valles Caldera holds the title of the oldest, having experienced its last major eruption 1.25 million years ago. This catastrophic event created a 12 by 14 mile caldera and released an estimated 70 cubic miles of magma, as noted on the USGS information page. Despite their dormant appearance, all 3 supervolcanoes are classified as active. Should they erupt simultaneously, a hypothetical scenario, it would undoubtedly be a global emergency. But how likely is such a scenario? Could even one of these supervolcanoes erupt in the foreseeable future? The answer is complex and uncertain. Supervolcanoes are rare geological phenomena, and studying their magma reservoirs is essential to understanding the risks they pose. The authors of a recent Long Valley study emphasize this point, stating that understanding the volume and concentration of melt in their magma reservoirs is critical for determining their potential hazard. However, they also noted that significant gaps remain in our knowledge. The characteristics of the magma, such as its chemical composition, temperature, and behavior within the chamber, are not fully understood. Any changes to these factors could significantly alter our assessments of eruption likelihood and severity. Volcanologists generally agree that a supereruption from any of these 3 volcanoes is highly unlikely in the near future. The processes leading to such massive eruptions take thousands to tens of thousands of years, and any significant changes in activity would be preceded by a variety of warning signs. According to the USGS, these warning signs include emissions of volcanic gases, earthquake swarms, and noticeable ground deformation. For smaller central vent volcanoes like Mount St. Helens, these precursors typically occur over weeks or months before an eruption. However, in the case of large calderas like Long Valley, episodes of unrest can persist for decades or even centuries without culminating in an eruption. Research indicates that only about 1 in 6 such periods of unrest at large calderas worldwide actually results in volcanic activity. Nevertheless, due to the potentially devastating consequences of a supereruption, these regions are closely monitored. The USGS and other geological institutions maintain extensive networks of sensors, satellites, and data collection systems to track seismic activity, gas emissions, and ground deformation in real time. This vigilance is necessary, as the impacts of a supereruption, while improbable, would be catastrophic. If a supervolcano were to erupt, the consequences would be far-reaching and severe. Vast areas surrounding the volcano would be blanketed in thick layers of ash, rendering the land uninhabitable and devastating agriculture. Entire ecosystems would collapse under the weight of the ash, and human infrastructure, including roads, buildings, and power grids, would be destroyed. Beyond the immediate vicinity, airborne ash would disrupt air travel globally, grounding flights for weeks or even months. The chemical composition of the volcanic gases, including sulfur dioxide, could create toxic conditions for plants, animals, and humans. Perhaps the most far-reaching impact would be on the global climate. The release of ash and gas into the atmosphere could block sunlight, leading to a phenomenon known as volcanic winter. This would cause temperatures to drop worldwide, disrupting weather patterns, shortening growing seasons, and triggering widespread food shortages. The cooling effect could last for years or even decades, making recovery an enormous challenge. In essence, a supereruption would represent one of the most catastrophic events in human history, altering life on Earth in ways we can scarcely imagine. Despite the improbability of such an event occurring in our lifetimes, the importance of continuous monitoring and research cannot be overstated. Supervolcanoes may be quiet for now, but their potential for devastation makes them a priority for geological study and disaster preparedness. Ultimately, understanding these immense geological systems is not just a scientific pursuit but a necessary step towards safeguarding humanity from one of nature's most formidable forces. While Yellowstone often captures the public's imagination, the other supervolcanoes, Long Valley and Valles, deserve equal attention for the insights they can provide into the dynamics of Earth's crust and the long-term hazards posed by volcanic activity. Could California's supervolcano be on the verge of erupting? A recent study indicates that while the Long Valley caldera has shown increased earthquake activity and ground deformation over the past 4 decades, these signs should not be interpreted as evidence of an imminent eruption. The region, located in eastern California near the Nevada border, is one of the most closely monitored volcanic areas in the United States due to its history and potential hazards. The caldera gained significant attention in May 1980 when a series of 4 magnitude 6 earthquakes struck the area. These events served as a stark reminder of the potential volcanic and seismic risks associated with the Long Valley system. In response, scientists intensified their monitoring efforts, employing increasingly sophisticated techniques to understand the region's complex geological processes. In the latest analysis, a team of researchers led by Zhang Jian, a geophysics professor at Caltech, used high-resolution underground imaging and advanced computational algorithms to investigate the caldera's activity. Their study focused on understanding the relationship between seismic events and the underlying magma system. The team's findings suggest that the recent increase in seismic activity is not linked to magma movement but rather to non-magma fluids, such as water and gas, migrating toward the surface. These fluids are released as the magma deep below continues to cool and crystallize, a natural process in long-dormant volcanic systems. Jean explained, "We don't think the region is preparing for another supervolcanic eruption, but the cooling process may release enough gas and liquid to trigger earthquakes and minor eruptions." This cooling process, while producing periodic minor geological events, significantly reduces the likelihood of a supervolcanic eruption. The last notable period of seismic unrest in the Long Valley caldera began in 2011, characterized by measurable ground uplift. However, activity has subsided since 2020, indicating a return to relative stability. Despite the primary magma chamber appearing to settle, the Long Valley caldera and its surrounding areas remain geologically active. Smaller-scale volcanic events, such as minor eruptions or gas releases, could occur, particularly along the nearby Monoinyo crater chain. This volcanic feature, located to the north of the caldera, has a history of activity and serves as a reminder that even small events can have localized impacts. The implications of these smaller-scale activities extend beyond the immediate vicinity. California's infrastructure could face challenges if volcanic ash, seismic shaking, or minor eruptions were to occur. Water supplies, critical power grids, and transportation networks, including Interstate 5, a major artery for the state, are all vulnerable to the effects of ashfall and ground instability. Preparing for such potential disruptions is a key component of the region's disaster management strategy. Moreover, the Long Valley caldera represents a unique opportunity for scientific research. As one of the most studied supervolcanic systems in the world, it offers valuable insights into the long-term evolution of volcanic activity, magma dynamics, and the interplay between geological processes and surface phenomena. The knowledge gained here not only improves our understanding of the caldera itself but also helps scientists better predict and manage risks at other volcanic systems worldwide. In the broader context of volcanic hazards, the Long Valley caldera highlights the importance of continuous monitoring and public awareness. While the likelihood of a catastrophic eruption is exceedingly low, understanding the caldera's behavior allows scientists to identify and respond to potential risks more effectively. Enhanced monitoring technologies, such as satellite imagery and ground-based sensors, are crucial tools in tracking subtle changes that might signal future activity. Ultimately, the Long Valley caldera stands as both a challenge and a resource for geologists. Its dynamic geological processes remind us of the immense forces shaping our planet, while its careful study offers a path toward mitigating risks and safeguarding communities. In this sense, the caldera is not only a feature of scientific curiosity but also a critical element in the ongoing effort to understand and live with Earth's natural systems. Finally, let's explore what could trigger the eruption of the Long Valley caldera. The potential eruption of the Long Valley caldera is a highly complex and rare event that would require a precise combination of geological factors. Although the likelihood of such an eruption occurring in the near future remains extremely low, it is important to understand the specific triggers that could theoretically set the stage for such an event. These triggers are not simple occurrences but rather intricate processes that interact with one another, contributing to the overall dynamics of the caldera. One of the most critical factors that could lead to an eruption is the replenishment of magma beneath the caldera. The magma chamber of the Long Valley caldera is not currently fully molten. Evidence suggests that approximately 27% of the magma in the reservoir is still liquid, with the rest having cooled and solidified over time. However, a sudden influx of fresh magma, which would need to be hot and buoyant enough to overcome the dense overlying rock, could lead to an increase in pressure within the chamber. This pressure could build to a point where it forces its way to the surface, potentially triggering an eruption. The timing and scale of such an influx of magma are extremely uncertain, and although the process might take hundreds or even thousands of years, the consequences of a significant eruption would be catastrophic. In addition to magma replenishment, tectonic activity plays a significant role in the potential for volcanic activity at the Long Valley caldera. The caldera is located in an area of high tectonic activity where the Sierra Nevada block meets the Basin and Range province. The region is characterized by frequent fault movement and crustal stretching, both of which can create stress in Earth's lithosphere. Large-scale tectonic events, such as fault slips or the stretching of Earth's crust, could destabilize the magma chamber beneath Long Valley. Earthquakes, particularly those with a high magnitude, could exacerbate the situation by fracturing the crust and creating pathways for magma to rise to the surface. These earthquakes could also potentially release trapped gases or cause ground deformation, both of which could further increase the likelihood of a volcanic eruption. Another significant factor that could contribute to an eruption is the accumulation of volcanic gases. As magma rises and cools, it releases various gases, including water vapor, carbon dioxide, and sulfur dioxide. In many cases, these gases are able to escape through fissures in Earth's surface, but in some situations, they may accumulate in high concentrations within the magma chamber. If the gases are unable to escape and continue to build up, the pressure could eventually become too great for the chamber to contain, leading to explosive eruptions. This process is particularly dangerous because it can result in rapid and violent eruptions that release vast amounts of ash, gas, and pyroclastic material into the atmosphere, posing significant threats to nearby regions. Ground deformation is another key factor that could indicate an impending eruption at the Long Valley caldera. Magma movement beneath Earth's surface can cause the ground above it to shift, leading to either uplifting or subsidence. As magma or fluids migrate through the chamber, the overlying rocks may fracture, creating escape routes for magma or gases. This process could trigger an eruption if the pressure becomes too intense. Significant ground deformation is often an early warning sign of increased volcanic activity, and monitoring these changes can provide valuable information about potential eruptions.